Good morning, good afternoon, good evening, wherever you are. Welcome. For those of you who have been with us before, welcome back. And for those who have not, we appreciate you joining us to learn more about CIQ. Go ahead and like and subscribe to this to stay current with us. This week, we're going to be talking about traditional HPC. And I have Greg Kurtzer and Robert Adolph, our founders, with us today to have that conversation. So let's go ahead and get started and just talk about what exactly does traditional HPC mean?
I can jump in and take that. Hi,
Excellent.
everybody. So I'm old. So when I talk about traditional HPC, usually that means something kind of very specific to me with regards to tightly coupled parallel application and a architecture that is designed to optimally benefit applications of that type. Now, HPC over the many years has expanded to basically say anything that's CPU bound or memory bound or IO bound, anything that's really hitting the hardware directly is starting to be considered high performance. And but when I talk about traditional HPC, I'm going to kind of go back to the foundation, back to the roots. And when we talk about how to build an infrastructure, an architecture to support a traditional HPC application, we usually start talking about an architecture that we've been using now for literally like 28 years called the Beowulf. And the Beowulf architecture has been an absolute just foundation and godsend to how we build traditional HPC resources. It's a flat monolithic architecture, but it's an architecture that's given us the ability for decades now to be able to scale and fairly easily scale these big HPC architectures and resources. So traditional HPC means something kind of very specific to me.
Excellent. Robert? Anything to add to traditional HPC?
No, the only thing I'd add is that this is a very big focus of some of our solutions, and it is an area that obviously our team has a lot of expertise. And our goal as CIQ when we started out was to bring that type of expertise together with cloud and hyperscale, and to enable the next generation of what that could be based on those experiences in both. So bringing together the knowledge and the know-how of how to run and do parallelization at scale that HPC has been doing for 20 years with the innovation that's in hyperscale and cloud is a driving force of what we've been trying to do for our whole stack. So not just for our traditional HPC stack.
So real quick, Zane, if you don't mind me jumping back in.
No, absolutely.
A really important facet of the Beowulf architecture is basically it's a specification of how to build these systems. And one aspect about it that's, I think, super important to talk about is the Beowulf is about commodity computing. This is about getting systems that everybody has access to and turning them in and creating a cluster with these systems, with this commodity hardware, creating a cluster using open source software predominantly to build these HPC resources and systems. And again, I just want to reiterate how important and critical that Beowulf has been for decades of research, science, and supporting these sorts of applications.
You mentioned something that's interesting. I hear the term open source get thrown around a lot. I've been around open source for a long time as well, but I know you two are extremely passionate about open source, maybe more so than a lot of others out there. From what I've been around, and one of the reasons I'm excited to be here is because you guys focus very much on open source and the community. And I want to understand from your standpoint, what should companies be doing? How should they be going about releasing open source software?
Oh my goodness, that's such an awesome question. And yeah, I mean, I've been I'm a biochemist by degree, and I have got really enamored. And what caused me to pivot my career was because I got so enamored and so excited about two things: Linux and open source. Going way back in time now, in the mid-90s, we were able to create genetic tools or tools for doing genomics using open source software. We were able to download Linux off of the internet for free, which, as you can imagine, back then was just it was mind-boggling to be able to download your operating system, put it on a bunch of floppy disks, and start installing Linux on a piece of hardware that you just got from Fry's or from wherever, and actually build a scientific tool out of that. So open source has had an extraordinarily profound effect in terms of how I see solving problems. It is, and I want to be very clear on this, it's a very beneficial and collaborative development model, but it's not a sales tool. It's not a marketing tool. It's not even a commercial asset, or at least it shouldn't be considered as such. Problem is that it is being considered as such by a number of organizations out there. And as a result, I've seen this many times, and I've even been part of this, where companies have decided to either adopt and control an open source project or not, or keep it within their umbrella, their corporate umbrella. And what we see is that open source project becomes a asset to that company, and that company can choose to leverage that asset for business purposes. The result of that is, well, to be blunt, they're holding it hostage. And they're holding that open source project and community hostage to benefit that company. Now, the way to get, and this is really critical, because one of the primary benefits of open source is not only the collaborative development model, but it's the freedom and stability that it gives to its users. And when this is being controlled and owned, in a matter of speaking, by a single company, by an entity, it loses a lot of that stability. And we've seen a number of applications and open source communities that were pivoted in the last, I'd say 5+ years to benefit a corporate agenda. And it hurts the open source community. It hurts the open source community quite a bit. I spoke with multiple companies who actually said, a couple of them have even gone so far as to say they actually feel better paying for their software and it not being open source, because they're kind of worried that that open source project's just going to go away if a company decides to change it. And they don't want that. They'd rather know that there's some stability, which is very odd because open source should be about that stability. So the way to get a project, an open source project, to be super stable is not to have a single company, even a really big company, standing behind that open source project and community and controlling it and running it. The way to truly get stability from an open source project is to have a wide variety of organizations, individuals, teams, people that are all standing behind this and not having it controlled by a single organization. And that it was a hard lesson that I've personally had to learn, and I've learned through mistakes. And moving forward, I am never going to support a company that I am either part of or running to basically own and control and hold hostage an open source project. So everything that we're doing from an open source perspective, we are not only putting it back out into the community, we don't even want to control it. We don't want to own it. We don't want to hold it hostage. We want that community to thrive. We want other organizations, other individuals and people to have control over that group, that project. And we believe in that wholeheartedly, that every open source project at this point that we have released and we have been part of, we don't control. And we've done that, and we're going to talk a little bit about that, I think, more as this webinar continues. But I think that's very, very important. And to be blunt, I challenge other companies to do the same. if you love open source, set it free.
I love it. Yeah, I think it's an important topic to talk about because there are a lot of open source projects that were fantastic that have gone away, and it's been, I mean, you have to pivot away from that product or that set of tools, and it can become very challenging for the enterprise or even HPC to go do that. So,
yeah, the only thing I'd add is that as a a product manager, as a person that's concerned about solving problems for customers, I find it to be one of the best ways for us to discover new use cases, new ways to solve different problems, because people are so unique and so creative that they come up and try and do things themselves. For me, it's a great way to stay in touch with exactly what our customers at CIQ want, at the same time as not holding it back and controlling it. Now, we can go shape it and do what we think we can go and do with our resources and our customers. So to me, it's the ultimate way to understand the community at large, and to serve them even better.
And Robert, you've talked about every startup and every company to some extent is always thinking about product market fit. And the way to get that product market fit, if you have an open source project, again, is to give that open source project to the community, and the community will shape and define what that project means and solves for them. And you get instant product market fit when you have adoption of an open source project that a particular company doesn't own. So it's so valuable in so many different ways.
I totally agree. I appreciate that perspective, guys. So back on CIQ, how does CIQ enable that traditional HPC stack? I know that there are several different pieces of that, but what does CIQ provide in that?
So we provide, so over my career personally, I've had a fantastic opportunity to create various capabilities that have been widely utilized in high performance computing. CIQ is basically pulling the innovations and capabilities that I've created among other people much smarter than I, that have basically been able to add value to HPC centers, to users, to people that are building these systems, commercial HPC, and we're now pulling all of those together to create a stack, a traditional high-performance computing stack. Now, three of the main pieces that we have been very close to in terms of innovation has been provisioning. It has been the base operating system that's running the resource, and it's been containers. And if you take those three kind of major pieces, you have the bulk of a high performance computing system. There's more components to this, like a batch scheduler, file systems, and whatnot. But this gives us the ability to start creating a turnkey solution for organizations from bare metal going all the way up through the stack. And that's where we're leveraging. So I'd really like to take a moment and kind of go through, if you don't mind, Zane, and talk about some of these three kind of major areas that we're contributing to that high performance computing stack. So to kind of jump in, if you don't mind.
Oh, absolutely.
Provisioning is a really big piece of this. And to kind of describe what provisioning is, it is if somebody wants to build an HPC cluster or even any kind of cluster, when you're talking about a cluster, it's a whole group of computer systems. And these computer systems are going to be built in such a way that they're going to work together to collaboratively solve a problem and a software problem. Now, if you just have a cluster that's fairly small, let's say in the tens of nodes, it might be possible just to go through and handle them like you handle any other server, right? Whether you're using config management or you're installing them by hand and then managing them by hand. But very quickly, when we talk about these clusters, we actually are scaling way beyond the tens. And we're scaling into hundreds, if not thousands, of compute resources. And when we do that, all of a sudden, the traditional kind of way that you think about maintaining a server needs to be pivoted a little bit, because it's just too many systems to do in the kind of traditional sense. So we've been doing provisioning of operating systems and resources and management of that cluster through a variety of tools. I created one called Warewulf back in 2001. And Warewulf brings some very unique features to the ecosystem. And one of them, probably the biggest one that it really changed and pivoted, was the ability to have stateless compute images or nodes. So what this means is, let's say you have a rack of 100 computers. You roll this rack up into the data center, you give it power, you hook it up into the network, and you literally can just start turning on nodes. You don't have to actually install them. You don't have to configure any of them. And you can just turn them all on, just power up the whole rack. And we've been able to build high-performance computing systems from the software perspective, from the moment the hardware is all set up, hundreds of nodes, and I'd even go as far as to say thousands of nodes. We can actually have the whole operating system built and ready to run across thousands of computers in an hour or two. And the whole thing is ready now for production. And that sort of ease of use and scalability put together is really what was some of the defining characteristics and problems that we were trying to solve initially with Warewulf back in 2001. Warewulf has done that very, very well. And as a result, it is still used today, and still part of the project today. And now we've got a number of different organizations that are also part of the project, and including OpenHPC, which, if you're familiar in high-performance computing, that is a Linux Foundation project to really help organizations create turnkey solutions for traditional HPC. So Warewulf is the provisioning subsystem for this. Now, one of the ways that Warewulf worked, I don't want to dive too deep in here, as you can probably imagine. I tend to blab a lot. But one of the things that Warewulf, one of the ways that Warewulf solves this is it uses a node image. And we used to call this the virtual node file system. Imagine a cheroot sitting in a directory on a control node somewhere, and that becomes the representation for every node that's going to boot. And that's how we've basically done Warewulf for literally over 20 years. Now, with Warewulf version 4, which is fairly new, the main pivot has been, instead of using this cheroot, this virtual node file system, let's pivot to using containers. And let's leverage the container ecosystem to be able to blast a particular container out to thousands of nodes and run that container directly on bare metal. And that's one of the major areas in which Warewulf has just been so incredibly helpful and useful to everyone in doing computing. The last numbers I heard, we had like 50% of the top 500 systems were running Warewulf. So a huge, huge number in terms of how many people out there are running Warewulf. So there's a lot of systems out there running Warewulf. And imagine if you can use the exact same tooling that you're using currently for whether they're user application containers or whether they're enterprise-focused containers. You have a CI/CD pipeline. You have all of your DevSecOps processes in place to validate those images. Imagine if you can now just import those into Warewulf and then blast it out to thousands of compute nodes or tens of compute nodes. It makes it that easy. And utilizing things like pre-configured containers, just like we use containers today. We can have a container for OpenHPC. We can have containers for Slurm, LSF, Grid Engine, PBS, just for the scheduling side. We can include InfiniBand. We can include GPUs, Lustre support, FPGAs, everything into these images. And then we can have these custom images that are targeted to do different things. people can now just import those images, just like you do with a Docker image, import that image into Warewulf, and then say, we want to build a Slurm cluster that's running Lustre or GPFS, and we need it to do X, Y, and Z.
Yeah,
Boom.
that's fantastic.
Done.
Yeah. I want to also point out, I mean, you've said it a couple of times, but starting in 2001, that's 21 years of experience with this thing running in different environments. And I think that's why it's grown so much. And it's exciting that it's continuing to grow and gain functionality and popularity. Every time I get on the phone, it seems like I'm talking to people who are using this today. So it's exciting. I know
you're just jabbing at my age right now. I got it. I know.
So I think the main takeaways from that is, I mean, you're talking about it's stateless, it's centralized, it's flexible, it's simple to integrate, and then there's a lot of pre-configuration you can do and add it to that CI/CD pipeline. So I think that's fantastic. I mean, from what I've been able to tell, it's also really easy to get it up and running, right?
Yep.
Excellent.
Robert, you came off mute. Do you want to jump in?
Yeah, so that's actually, a lot of topic of discussion is where we're going to take Warewulf and what's next. And obviously the community drives a lot of that. There's a lot of great folks in the community, representing a lot of large organizations. What I would say is obviously a very simple GUI type of graphical interface to help people that are newer at these solutions to get them up and running extremely efficiently and effectively. This is an extremely lightweight solution, so it's designed specifically for this, potentially adding some stateful capability to it, and some APIs to make it more extensible. And then lastly, I would just say that potentially utilizing this platform as a large scale imaging as a service solution for customers of Rocky Linux, for customers of HPC. So beyond just HPC, we think we could utilize this lightweight capability at scale.
That's actually sorry, Zane. Yeah. I know I talk a lot. That's a really good point, Robert. As we've been talking to enterprises, it seems as though that you can kind of generalize how people manage their resources based on size of the organization. So we have on one side, we have people that are doing physical installs, doing system administration almost by hand on number of systems. Then we've got this middle ground where the majority of organizations seem to sit, which is they're using some sort of kickstart and configuration management based solution to manage that infrastructure at a larger scale and to be able to do management of the config management system using even something like Git. So all the configs, everything is in Git, which is then being propagated via configuration management, and you can manage a large number of resources. But what I didn't realize until fairly recently was the other extreme, right? Again, one stream is everything by hand, going all the way past configuration management. And looking at it at this extreme, what we're seeing is organizations, very large clouds, some hyperscalers, they don't do configuration management even. Well, they do to some extent, but for the most part, they're doing imaging. So every system is being blasted out as an image. And what we've been doing in high performance computing is extraordinarily similar to what's been happening at the extreme scale of cloud and enterprise, where we're handling and managing this from an imaging perspective and provisioning out those images of operating systems out to those resources, whatever those resources may be or require, in an extraordinarily scalable and efficient means. And that's one of the areas that I think it was really, I just learned about this fairly recently, that's how they're doing it. And I thought it was super cool how similar we've been doing it from an HPC perspective as well as the extreme scale. So one of the points that Robert just made is, what if we can change that barrier of entry using something like Warewulf to help organizations even do more imaging as a service across their organization, and maybe even couple that with configuration management to where we're supporting even smaller enterprises to mid-size and large enterprises, all using these same sort of methods and models. So that's something that yeah, thank you for bringing that up, Robert. That was a really good point.
Yeah, I think it's really interesting. And we've been talking about this from an enterprise perspective for many years of getting to being able to, as soon as it's time for something new, tear it down, build new, and build it up. I mean, you got the blue-green deployments, and it's all fine and good in theory, but rarely does it ever actually work the way you want it to. So it's exciting to me to see something that there are people making progress down that path. I mean, I feel like this has been 10 plus years in the enterprise. We talked about trying to get to that level, and you just don't see a lot of people making that kind of progress towards it. So I'm excited to see where this goes as well. So I know from an HPC perspective, we have Warewulf to do provisioning, but you got to provision something. So that next layer up is Rocky Linux. So, I mean, let's talk about Rocky for a minute.
So I'm going to start it from the perspective of the relationship between CIQ and Rocky. And just to hit the elephant in the room, I'm the founder of Rocky. I'm also, founder and CEO of CIQ. So one of the decisions that I made, again, looking back at our open source stance, our goal is not to own, control, or hold any of our open source capabilities hostage. So we didn't want to put this in CIQ. We wanted this to be a separate project and a separate organization. And that's why I created the Rocky Enterprise Software Foundation. But CIQ has been, along with Rocky and with RESF, as a supporting, as a founding supporter and partner of the organization. So right from day one, CIQ and myself and others at the company have been backing what we've been doing with Rocky. And our goal, again, not to do anything from a corporate agenda perspective. We really just want to facilitate wherever this community wants to go. Our goal is just, if anybody needs help, we want to earn that business. We want to prove that business, and that's our model, and that's it. So that's the relationship between the two, and that really leads to what we could be offering in terms of the operating system portion of this stack. So we add some various benefits on top of the base Rocky Linux. And the other thing I'll mention is CentOS is about, in our approximation from everything, all the metrics that we've seen, it's about 20 to 25% of all enterprise resources, cloud instances, containers worldwide. So that's a big number. It's a really big number. Now that has just been end of life. and Rocky is stepping up to become that replacement, to become that alternative to what CentOS has been and how CentOS has been trusted for so many years. And we're hoping to do it better, in the sense that there's not going to be a single company that controls that. Rocky's going to be completely neutral from that perspective, and we're going to have lots of companies being part of that. But CIQ being one of those companies that's helping and sponsoring and partnering to bring value to customers, we're there to help. We're there to make sure that if anybody has any questions, if anybody has any problems, we can offer that. We can become that enterprise level production support arm, as well as offering some services. Now, we already talked a little bit about imaging as a service, but there's also something else that we've had a lot of really great feedback from with the community and customers, which is repositories, repos as a service. Imagine if a particular organization or site can be able to easily overlay their custom changes to the operating system and make that operating system theirs for their organization, all their customizations, everything that they need for that organizations, even configurations being pushed out, default configurations being pushed out and managed via a repo. And that repo has a bunch of code around it that allows organizations to easily add packages into this, easily build packages through that, do cryptographic signing, validation, and everything that they need as part of that repo. You can think of it almost like what Satellite provides, but there's no licensing per node. So it basically gives you the ability to manage, to update, and control what an organization's Linux needs are without ever having to worry about licensing costs or anything along those lines. So repo as a service, we're getting a huge amount of positive feedback. We're also focusing a lot on FIPS and other security accreditations. That has really been huge for federal. But what surprised me was there's a lot of companies out there that really prefer to know that those accreditations have been met, and that they can trust the operating system. So we are moving forward with FIPS. We have a timeline. If anyone's interested in that timeline, please let us know. And we also have the ability to block security exploits that use buffer overflows as the vector of attack. And imagine if all past, present, and future exploits, again, using buffer overflows, were mitigated. We have that ability to bring that level of security directly into not only the base operating system, but also containers running Rocky as that base image. So what we're doing from the high performance computing perspective is to add all of this into that traditional HPC stack. And you can imagine that coupled with Warewulf, and then coupled with containers, creates an amazing base platform for doing traditional HPC.
Yeah, so Zane, I'll do the opposite this time. So usually I take Greg back from the open source to CIQ and solutions we're doing. I'm going to go the other way since he told everybody about our repo as a service solution. So the other thing I would highly recommend is there is a special interest group in the Rocky community that is specific for high performance computing. Every engineer at our company has deep understanding of high performance computing. There's tons of people in the Rocky Enterprise Software Foundation that have deep high performance computing background. Rocky's being tested on all sorts of high performance computing apps and use cases and storage models, etc. I can tell you that folks in the testing community are high performance computing experts. So what I would highly suggest is getting into that community aspects and really, looking around and seeing all the resources there, because I think you'll be massively surprised by the compatibility of Rocky Linux when it comes to high performance computing applications and solutions at a totality.
You know, I completely forgot the point that I was getting to when I was talking about CentOS being such a big piece of the market. At 20 to 25% of all enterprise resources. In HPC, it's closer to 70 to 75%. So Rocky not only has a lot of interest in enterprise, hyperscale, and cloud, but the interest in high performance computing is massive. And if you look at who are the people that are part of that Rocky community, two of the people, for example, the two people that lead the testing group are both from HPC centers. So we definitely have a large amount of interest and background with the high performance computing section of the industry. And again, just to reiterate what Robert just said, we have a SIG HPC, a special interest group specifically designed to further enable high performance computing on Rocky. And if this is something that people are interested in, we will post the link to the to our Mattermost, which is basically our open source Slack, that you can join in, and then you can search for the channel that's SIG HPC, and please join. We'd love to have you as being part of the Rocky community.
Excellent. Thanks, Greg. So now we have provisioning, we have an operating system. Now it's time for people to start deploying apps. And I mean, nowadays everybody wants to talk about containers and CI/CD. So I know you kind of alluded to it a little bit earlier with Apptainer, but tell me about Apptainer. Where does it fit in this model, and how does we've got the base, we've got the OS, and now what?
So Apptainer started life as Singularity, and a lot of people within the high performance computing world know Singularity very, very well. It has been the absolute dominant market share leader of containers within HPC. If you're not in HPC, it wouldn't surprise me if you've never heard of Singularity. But if you are part of the HPC community, I'd almost put money on that everybody has heard of this and potentially even been using it, because it has become such a prevalent and critical piece of high performance computing infrastructure. And this is because when containers were really starting to evolve and gain traction and publicity and interest in the enterprise and cloud space, the methods for dealing with the runtime for containers were very root kind of centric, and it didn't allow very well for a Beowulf style architecture that may have hundreds or thousands of users logged into them, with none of them having any privilege or access above what they would have as just a generic non-privileged user. To give them access to a container subsystem that was all running as root would have defied all of our security aspects, and we would basically, that would be a security exploit if a user has the ability to control the host operating system, and that's exactly what Docker would have given them at that stage. So that, plus several other facets, in terms of how do we make good use of GPUs and InfiniBand? How do we do things like MPI, which is the message passing interface, which is the library in high performance computing that we use to enable parallelization of compute jobs across node boundaries. So we can actually have 100 nodes all running the same application and doing, communication between those nodes in a very highly optimal manner on whatever network backplane you have. We had to figure out how to do all of that. How do we integrate with a batch scheduling system that is controlling all the resources of that HPC system? So long story short, we really needed to come up with a way of integrating containers into an HPC system that fit with the HPC architecture and use cases. And that was what Singularity did. As a result of that, within just a matter of months, Singularity went from just an idea to it was installed probably on the majority of big HPC systems that supports containers, again, in a matter of months, not years. So uptake was incredibly fast. It solved a critical problem. It was highly optimized for high performance computing use cases and architectures. Supports things like MPI, InfiniBand, GPUs, file systems, any batch scheduler that you want. Allowed non-privileged, regular, average, ordinary user out there to be able to leverage any container they want. And so it really took off. And we've done things even differently than the traditional kind of container ecosystem. Like we have single file-based containers that we can cryptographically sign and encrypt. So we actually bring even a level of security that differentiates the container supply chain further than anything else, to my knowledge, that's even out there today. So Singularity made a bunch of great strides. We really wanted to ensure that Singularity stays open source and in the community for the long haul. And we decided in a collaboration with the Linux Foundation to bring Singularity into the Linux Foundation and allow the Linux Foundation to take over ownership and control of the project. And the one request that we had was, well, that's great. Everybody was on the same page, but they just asked us to rename the project and so they can properly protect the copyrights and trademarks. So we renamed the project. We went out to the community and we said, we need to rename the project if we're going to move this into the Linux Foundation. And we gave a few suggestions. A few other suggestions were offered. And Apptainer was the voted lead. So we ended up renaming the project to Apptainer. So Singularity at this point has been renamed to Apptainer. We have a thriving community around this. We're part of the Linux Foundation. And it is the goal of this, and one of the goals of moving to the Linux Foundation was, how do we better cross-pollinate between the high-performance computing world and the enterprise and cloud world in terms of container and container infrastructure? And so we've been focusing a lot on that cross-pollination and leveraging those resources on both sides.
Excellent. So Robert, I know you're very passionate about the security aspects of Apptainer, Singularity, and kind of that single file, being able to have the cryptographic signature and all that. You want to dive into that a little more?
Yeah, I still remember the first time Greg explained to me in detail what he'd created. I said, wait, let me get this straight, Greg. So basically you're saying that I can take my application and move it to any cloud, any Linux operating system, and running on any piece of hardware or anywhere I want in the world, and not be completely locked into any cloud or anywhere or any specific piece of hardware ever again? And he said, yeah. And then I said, wait a second. So you're also saying that it's immutable and it's perfect for every kind of research that's possibly available out there? Yes. And it's immutable? Oh, okay. And reproducible? Oh, okay. You literally just solved like 25 problems that I've heard from customers over and over and over again, right? So it's kind of like I heard everybody talking about serverless, and I'm like, why would I want serverless when I can just move my apps anywhere I want in the world? Why would I want to be locked into anything, right? So this to me is huge. Greg said something that's really important. It's software supply chain security aspects. We can cryptographically sign every step of that process. And we can also sign for security signatures, for deployment signatures, DevOps signatures, etc. And then with our new platform, we can actually even ensure that that doesn't get run anywhere unless it has all the correct signatures. So this was a basis of a lot of the future steps that we took. And it's all because of those 25 problems Greg solved with that one, as Greg says, Pandora's box that he opened. And that led us into, creating the next generation of high performance computing that we've been working on as well. And we'll talk about that next week, though.
Excellent. So how does CIQ bring all of this together? What does it actually mean for a customer?
Some feedback that we've gotten is, and this is both from vendors as well as customers, they want a turnkey solution. They want to know that they can come to a single location and get the entire foundation of what they want to build, and know that that can be supported and it integrates easily. So we looked at all these different pieces that we've created and we're continuously maintaining and contributing to. And we said, okay, let's put these all together into that turnkey solution. And let's build a traditional HPC stack specifically to be easy to deploy, highly scalable, very, very flexible, and become that base foundation for HPC centers, HPC consumers, and even enterprises that are looking at doing compute-focused workflows. And let's simplify that. Let's democratize that in such a way that anybody can go and do this. And what I love about how we approach this was we were not going to make any sort of architecture statements or compatibility options. I don't know if somebody wants to use an NVIDIA GPU or an AMD GPU. I don't know if they want to use an FPGA. I don't know if they want to use Slurm, if they want to use LSF or Grid Engine or PBS. I've got no idea what a particular customer is going to want to use. What I want to do is I want to provide them that infrastructure substrate that they can go and build the tools that they need to create and solve their problems. And that's what we've created. We've created a turnkey solution that can go and build up an open HPC cluster or a custom cluster or however they want to build it easily and efficiently and scalably. So it's very simple, it's flexible, it's capable, it's scalable, it's secure. And that was our goal, to bring all of that together. We do have some organizations that are leveraging us for kind of an a la carte stack in a matter of speaking. Some customers are strictly for Singularity and Apptainer. Other customers are focused on Warewulf and or Rocky. Actually, we have a lot of customers on Rocky right now. So it could be a la carte as well. However an organization wants to deal with this, we're here to support the organization. And it's one of the things, and this is a little bit off of topic, but I think it's really super important to mention. We are offering both capabilities and licensed values on top of open source pieces, as well as offering services and support. And for services and support, most organizations are pretty much doing what the legacy model has been. And when we first started thinking about how would we do this, we decided to completely rethink and be willing to throw out every idea that's not working and that's not beneficial to the customer. And what we decided to do is make sure that everything we are doing is about enablement of the customer. And if it's not enabling the customer, if it is a value to us and not the customer, then that's not a win for us. So I can give you an absolute easy example of this. Most or many organizations will charge for support based on core or socket or even nodes. And some organizations really have to use nodes to get it through their procurement department, but most people don't like it. They don't want to have to count the number of systems or resources that they are paying for support. They don't want to do that. So who does that model help? It helps the company who's offering the support, not the customer. So we basically, if a customer really came to us and demanded per node pricing, we'll do it. But we want to make sure that we were offering something better. Even site licenses can be difficult. So we decided to completely rethink this. And here's what I can say. Every person, every organization and team that we have shared this model with, even the teams that said we never want support because we have a great team and we don't need the help and we don't need the insurance policy, even those companies are now joining with us because they love the model and they see how we can now help and add value to their team as people, as individuals. And so if anyone is curious on exactly what that looks like, reach out to us and we'd be happy to walk you through it.
Absolutely. So, guys, if you have any questions, go ahead and start posting those. I know, Robert, you were about to say something.
Yeah, I take it one step further. So, Greg told you about some of our design principles. One of them was being modular in how we approach this, and having the building blocks, but also making it all work better together as well over time. So, if you were a Dell customer of Dell hardware, you could utilize their Omnia stack and utilize Warewulf, Rocky, and Apptainer. If you're an HP customer, you could potentially utilize Rocky and Apptainer and maybe keep some of their secret sauce that they utilize. If you're a customer of Penguin, you can utilize Rocky, you can utilize Apptainer in a traditional stack like many folks do today. And that's just an example of some folks you could partner with. Supermicro, you could do the exact same thing. You could use our whole stack, or you can use pieces of it that make sense to facilitate the additions to what you're doing. So definitely work with your OEMs. One of the overriding principles that Greg and I talked about a lot about all of our open source projects and all of our projects in general was to have every cloud, every OEM, every component of a server, and every ISV that could potentially run on any of those environments as partners, as sponsors, as folks that we work with on a regular basis. And it's not by name. If there is an issue with a system, I want to be able to call that OEM from our support group, explain to them what's going on. We want to not make it so that the customer isn't getting served. We want people to get their problems solved And if there's a driver that needs to be executed on or something that needs to be done, we're there to help them do it. And then the last thing I'd say on containers, obviously there's a lot of libraries and OS capabilities that get built inside of there. We have a full staff and team to enable the entire stack that we're talking about, and giving your application speed and life and flexibility at the same time as giving your end users and your admins complete control. So that's what we were doing when we were designing all of our software, and potentially in our open source solutions as well.
Perfect. Well, guys, if there aren't any questions, I know I just heard Greg's reminder for his next meeting pop up. I know you're a busy guy, so I want to respect your time, and I appreciate you joining. Again, we ran out of time and didn't get a Greg story. Sorry, maybe next time. Maybe we can push for that. Or maybe we can just force Robert to tell a story. We'll see. We'll see where we get. Anyway, appreciate you guys joining again. Go like and subscribe, and we'll see you probably next week.
I can guarantee there'll be a story next week.
Awesome. Thanks, guys.
Bye, everybody.